Hello everyone, so today we're going to be learning about the area of a sector and how we can use a specific formula to find the area of a sector. So by an area of a sector, I mean finding the area of this yellow shaded bit here. So finding a formula that we can use to find that area. Okay, so to start off, let's take a look at the formulas. So we have two different formulas we can use depending on what units the question gives us. But before we get into that, let's just break down the formulas. So to begin with, we have pi. So we all know pi is just 3.14. So that's just a constant, and it doesn't change depending on the question, so it's 3.14. Okay, next up we have r. So r, that's going to be the radius. So if we take a look at this circle we have here, the radius would be this line here. That would be the radius. So that could be something like 5 centimeters, let's just say as an example. Okay. And then the next part we have is theta. So theta is where these two different formulas come in. So theta is the measure of that angle there. So that there is going to be theta. And theta can either be given to us in radians or degrees. So if it's given to us in radians, we're going to use this formula. While if it's given to us in degrees, we're going to use this formula. And on the next slide, I'm going to show you how we know which to use. Okay, so to understand the formula, we're going to take a look at how it works. So if we look at this first bit of the formula here, that's just the formula for the area of a circle. You can recall from previous years that the area of a circle is just pi r squared. So in this situation, we have a circle, and we're just multiplying the radius, whatever that is, by itself. We're squaring it, and then multiplying it by pi. So pretty easy. But when we're trying to find the area of a sector, so something like this, now we're multiplying it by a ratio of the number of degrees within the sector by the total number of degrees, or radians, we can also do it with radians, of the entire circle. Okay, so let's think about how this is going to differ for finding the area of a circle versus finding the area of a sector. So say we're finding the area of a circle. I'm just going to draw another circle down here. We would have the radians, so that again, and then the total number of degrees around, so that would be 360. So we'd have that the area is equal to pi r squared again, times 360 over 360. So that's just multiplying it by 1. So you get the same overall formula as the area of a circle. Now let's say we're not doing a circle, we're doing a sector. And let's say the sector, just to make it nice, is 90 degrees. So a nice right angle. So in this case, it would be the same formula as we were using before. So A is equal to pi r squared times theta over 360. But this time, theta is going to be 90 degrees. So that's going to be 1/4 of the area of the circle, which makes sense because 90 degrees, that's 1/4 of the circle. So we're trying to find 1/4 of the area of the circle. So that's, I find, the easiest way to help yourself remember the formula for the area of a sector, because you're just trying to find a specific proportion of the total area of a circle. It's kind of confusing, but I hope it'll start to make more sense with some examples. Okay, so let's take a look at this. So from the diagram, find the area of the shaded region. Okay, so again, using the formula, so A is equal to pi r squared times theta over 360. So we know 5, that's going to be our radius, And 60 degrees, that's going to be our theta. So we can just substitute that in. So pi is equal to 5 squared times 60 over 360. So this means that we're going to have the area of what this total circle would be, which would be 78.5, because that's pi times 5 squared, so pi times the radius squared, area of a circle, multiplied by 60 divided by 360, which is 1/6. So we're trying to find 1/6 of the area of the circle. And that's going to come out to be 13.1, approximately. There's definitely some rounding happening here. So that is 13.1 is 1/6 of the area of the entire circle. Okay, so let's look at another example. In this case, well, if we look at this one, we can see that we were using the formula for degrees because we had 360. But this one, we're going to be using the formula for radians because we're given the number, the measure of the angle in radians, pi by 4. Typically, you know something's given to you in radians when there's a pi involved. Okay, so let's use the formula again. So A is equal to pi, r squared, area of a formula, times theta over 2 pi. And recall that 2 pi is just in radians, it's equivalent to 360 when we have it in degrees. So in this case, our radius is 6, and our theta is pi by 4. So we're going to have pi times 6 squared times pi by 4 divided by 2 pi. And also, usually when we're working in radians, we're not actually going to calculate the final answer using our calculator. We're just going to simplify the question. Okay, so that means the area of the circle, which would be 36 pi. I'll write this out better. So 36 pi, and then multiplied by, I'll just go through all of the steps just so everyone sees what's happening. Since we're dividing by a fraction, we're going to do this. And then, so 36 pi times pi by 8 pi, and then we can divide out the pi's here, because we have one on the top, one on the bottom, and we'll put 8 over there. So we have 36 pi over 8, and then we can simplify it a little bit. And with simplifying, both of these have a common denominator of 4, so we're going to divide 36 by 4 and divide 8 by 4, and that gets us 9 pi by 2. So that's the area of this sector. So I hope through this video you've hopefully gotten a better understanding of how the formula works, as well as how we can apply it to specific situations. Thank you for listening.